Welcome everyone and thank you for joining us for our expert sessions. These are short webinars taking place every 2 weeks and last no more than 30 minutes, bringing you valuable insights from the industry experts. Today's session will be presented by Sonny Solanki, who's Senior Technical Manager at I-Gard. Sonny is an electrical engineer with a bachelor by McMaster University with 8 years of experience in protection systems and relays. Through his career, he has educated consultants and end users on the benefits of integrating electrical protection products into their designs to enhance personal and equipment safety. He specializes in providing commercial and technical support for various projects and applications, including high-resistance grounded systems, low-resistance grounded systems, hybrid HRG systems, ground fault and arc flash protection systems, resistor-based solutions, and personal protection products. We are excited to have hear him today, and we appreciate your participation. Thanks for your time. Thank you, Sonny.
Thanks, Andrea, for the introduction. Hi, everyone. My name's Sunny, and I'm the Senior Technical Manager at I-Gard, and today's presentation is on frame voltage protection and compliance with Canadian Electrical Code, National Electrical Code, and mining standards and codes. So let's begin. For frame touch voltage, the definition is frame touch voltage protection is a critical safety feature that prevents electrical shocks by ensuring the metal frames and enclosures of electrical equipment remain safe to touch even during electrical faults. According to IEEE Standard 80, touch potential is defined as the potential difference between ground potential rise and the surface potential at the point where a person is standing, while at the same time having a hand in contact with a grounded structure. So you could see the image on the right where the person is touching between two metal to metal structures, each that are separately grounded. That's a touch voltage. And in addition to that, you would also see touch voltage when touching an electrical equipment that is grounded. Now, why is it important to have frame touch voltage protection? Well, we want to reduce the risk of electric shock in high-risk environments, protect personnel working near energized equipment, and enhance workplace safety by addressing potential fault conditions that could elevate the ground's potential and cause voltage to be present on the frame. So what can cause touch voltage? So the first one is ground potential rise. So even if the fault is not contained within the system that you're connected to, if you have a fault, let's say, on this in-between path between the fixed substation and a movable substation, and the fault is occurring on the primary of the transformer on the movable substation, this will create a ground potential rise in the location near the fault. And if a person touches the mobile equipment that is still connected to the same ground at remote Earth, then the person can experience an electrical shock. The second method is if there's ground fault at the equipment over here where fault B is indicated. In this case, then there would be a touch potential between the energized equipment as well as ground, and as a result, an electrical shock can occur and create a hazard for personnel. Now, if we look at the M421 standard, it says that grounding systems connected to movable or mobile electrical equipment shall be designed and installed in a way that prevents the transfer of potential exceeding 100 volts to movable or mobile equipment. And the duration of that transferred potential shall be limited to 1 second or less. And then in addition to that, when we're doing the installation, we have to measure after to ensure that the transferred potentials do not exceed 100 volts. And where applicable, you would apply the split factor as I defined in IEEE 80 into consideration for your ground potential rise calculations. For the National Electrical Code in Article 250, grounding and bonding, In 250.188, it indicates for grounding of systems supplying portable or mobile equipment that systems supplying these types of equipment over 1,000 volts, other than substations installed on a temporary basis, shall comply with 250.188 A through F. So for portable and mobile equipment over 1,000 volts, they shall be supplied from a system having its neutral conductor grounded through an impedance. So that's like an impedance grounded system or resistance grounding. And where a delta connected system over 1,000 volts is used to supply portable or mobile equipment, a system neutral point and associated neutral conductor shall be derived. For exposed non-current carrying metal parts, they have to be properly grounded to the point at which the system neutral impedance is grounded. And in terms of ground fault current, the voltage developed between the portable equipment and ground by the flow of maximum ground fault current shall not exceed 100 volts. For ground fault detection and relaying, there's a requirement to detect faults as well as monitor the continuity of the ground loop and the grounding conductor. And isolation is also important in terms of the grounding electrodes for portable or mobile equipment. They should be separated by at least 6 meters from any other system or equipment grounding electrode. And that way we can kind of reduce the impact of that ground potential rise that occurs at the point of fault. For trailing cable and couplers of system over 1,000 volts for interconnection of portable or mobile equipment shall meet the requirements of Part 3 of Article 400 for cables and 490.55 for couplers. So at I-Gard, we do have a solution in terms of ground fault ground check, and that is our GCHK 100 relay. It also monitors frame voltage and gives you the capability of customizing the relay to suit your needs based on non-fail-safe and fail-safe modes, ground fault pickup levels, and various other different features that you can utilize, including ground fault delay and ground check features. So it can detect voltage between frame and ground exceeding set thresholds up to 100 volts. It responds within 100 milliseconds for standard detection and 30 milliseconds for voltages greater than 100 volts AC. It gives comprehensive monitoring to identify ground loop shorts, open conditions, and internal leakage coming from ground fault. And it also provides operator protection to prevent electrical shock risks from ground connection failures or equipment faults. On the front of the relay, we have dip switch settings, and we also have our map for the dip switches directly on the relay, so it's very user-friendly. Our frame voltage settings are between 40 to 100 volts with 20 volt steps in between, and these are configurable as well on the dip switches. At the top, we have the fuse portion, which can be replaced if a fuse gets blown within the field. So if there are any questions, feel free to ask, and I'll be covering those right now. What is voltage for standard detection of 100 milliseconds? So if the voltage is less than 100 volts AC, then it responds within 100 milliseconds. But if it's greater than 100 milliseconds, greater than 100 volts AC, then it's at 30 milliseconds because it's easier to detect. How do we get to the schematic of the relay? How is it installed? You can view our manuals on our webpage, and that would give you the information on how this unit is connected. We can also provide you with the manual and brochures alongside the presentation slides that will be sent to you. Is this ground monitor relay works for high voltage substations too? You can potentially use it on trailing cable as well, but we also do sell ground fault monitors by themselves without the ground check feature if needed, and that's where you can use the Sentry relay, which has a trip range between 0.5 amp to 1200 amps. and tripping within a second or less to meet those requirements of ground fault only. If ground fault ground check is needed at high voltage, then the GCHK 100 doesn't have voltage limitation. In addition to that, we also are compatible with 6-volt and 12-volt Zeners, as well as competitor-based CTs. And we have 2 different inputs we can take, either 1 amp or 5 amp, which gives us more flexibility. And the Zener is a very common ground check configuration for all providers. So it is very easily adaptable to our relay as well. The purpose of ground check is applied to indoor frame and electrical equipment as well by code or not. Mostly in the mining code, it stipulates that this ground check feature needs to be provided simply because your mobile equipment can be a few kilometers away from the main substation feeding it, and as a result, there's a need to monitor and ensure that the grounds are still intact at the mobile equipment to protect the workers from this frame potential that can occur. Is this relay able to be modeled in ETAP for arc flash calculations? I am not entirely sure, but I think that they do have some standard settings that can be configured for different ANSI codes, but I haven't checked. Do you have any wiring diagram of ground check? Yes, I can definitely send that to you, Sanjay, so I will get that information to you. What would be the beneficial use of a relay such as GCHK 100 in a warehouse environment? If so, how would it be integrated? Good question, Gerald. I think ground fault ground check relays are typically used in mining applications rather than warehouse environment. So unless your warehouse is utilizing very long cable connections, it's likely that you may want to opt for just ground fault only, in which case we do have M-Gard products and Sentry products which do just ground fault detection without the need for the ground check feature. Can you explain more on the split factor in CSA M421-23? I do have a paper on this and I will send it to you. Just send me an email. I'll write you my email down, Arvind, so that you can get that paper from me. And if anyone else wants it, my email is in the answer pane over there. Where does the output of the relay to be wired to shut down equipment or isolate electrical equipment? So, Sanjay, the relay has dry contact outputs that can be wet with a voltage of 120 volts AC, and then they're normally open in normal operation and will close when a fault is detected to trip the breaker that is connected to those dry contacts. Can the relay communicate to other control systems such as DCS? Yes, it needs an M-Gard SIM, which is our communication module, I guess, and screen. And then it can use an RS-485 connection to the DCS. If your DCS is not accepting of a certain Modbus protocol or RS-485 connection, you may duplicate the contacts of the dry contacts and use them in a manner such that your DCS can read it. Okay, I think that's it. I've recorded the email addresses as well. All right, I guess that concludes the questions. thank you very much for showing up, and stay tuned for our next expert session. Thank you so much. Take care.